Hello, I'm Eric Snodgrass, and thank you for watching this in-depth ag forecast brought to you by Nutrien Ag Solutions. I'd like to pick up where we left off on Thursday, and that was with the discussion about the performance of long-range weather forecast models. We looked at how the models performed last year versus reality, and then we talked about some of the shortcomings, specifically with their, some of their speculative forecasts with respect to ocean temperatures. And the reason why we talk so much about ocean temperatures is because when it comes to seasonal weather forecasting, it's one of the most dominant drivers we have. So we're going to start there. This was the July, August, and September forecast from the April model run this year. And what the models really changed in terms of their forecast from the previous months was to keep the La Niña around in a much more aggressive way. Previous model runs have brought in quite a bit of warm water in here and almost made us think that we were going to start to see the emergence of an El Nino after having two back-to-back winters of La Niña conditions. All right. The shift that happened was largely because during the month of March this year, we saw a resurgence of this La Niña. So all of the models were initialized with that, right? But there's two other pieces we need to pay attention to here. The first is in the North Pacific. Right into this region here where I'm kind of hatching, this is the area we got to watch out for those colder water temperatures to persist. It's a part of the negative phase of the Pacific Decadal Oscillation. And also the ocean temperature pattern in the North Atlantic, specifically with the Atlantic Meridional Mode or the Atlantic Multidecadal Oscillation. Both of those two things are important to watch here. Now, we cover all of that, and I just want to tell you why. So many of the meteorologists, we see this day in, day out, but let's make sure we really understand why. Because it is primarily because of this ocean pattern that we're seeing this for the forecast for summer on precipitation. Really active southwest monsoon, expanding drought in the central United States to the Canadian prairie, and an active hurricane season. So we covered that a lot last time. We also knew that this is where the models were going to keep the majority of the heat. So why are they doing that? And is there support in other models? Well, this was released on Friday, so let's have a quick discussion about this. It comes from the National Multimodal Ensemble. What are they looking at in terms of ocean temperatures? Well, that same time period, June, July, August, you can see there is still expected to be cooler water here. And they have a full and robust La Niña. You can also see the response in the Indian Ocean, where we have the negative phase of the Indian Ocean dipole, where there's warm water here and cold water there. Now, there's another part to this, though. Let's go look at the results of that. So how about we go to June, July, August precipitation rate forecast. And the model ensemble average looks very much like the European, doesn't it? So driest in through here, active monsoon, active in the east, partly due to hurricane activity and partly due to just the flow of the atmosphere. So every bit of this is kind of predicated on the evolution of this map. And that's why I continually stress watching ocean temperatures here and here in the Pacific and how warm the Atlantic gets. So I'm going to show you why I watch that just to make it clear in case you've not seen this before. So I'm going to stitch together a group of years that are pretty significant in the central part of the United States. They're also significant on both coasts as well. July through September, you can see the years 76, 83, 99, 84, 13, 12, 91. You see the years I'm pulling out here. What we typically saw during those years was cold water in through here, possibly a resurgence of a weak El Nino after a La Niña, but still cold water in the Central Pacific. Now, because of that, because of this ocean temperature pattern, the atmosphere and its momentum, okay, the transfer of the heat out of the tropics into the mid-latitudes was affected. And the way that it was affected was such that it produced pretty frequent troughing somewhere between the Bering Sea here and the Gulf of Alaska. So the jet stream had to dip south of that. Now, simply due to jet stream dynamics, in other words, the typical wavelength of the jet stream pattern, it tends to flow into this side of the West Coast and then run up over a ridge here. And the net effect of this ridge that was in place was to produce high pressure somewhere in the plains through the Midwest. And that effectively had circulation near the surface. So watch the last circle I draw here. That kind of came around like that. And while this was cooler for the west, cooler for the east, it was extremely hot and dry with very little transport of moisture out of the Gulf of Mexico. So that pattern right there is one that the West Coast would benefit from, the central United States would have a terrible summer out of. When we look at the opposite of this, so wet years for the primary corn and soybean belt, the midsection of the United States, like 93, 16, 92, I mean, you can see the years listed down here. You can almost see the exact opposite. the jet stream became blocked up somewhere in the Gulf of Alaska. And the flow came over the top of that and then dove here and then ran up over some sense of a southeast ridge. The net effect was to give southwest flow across the midsection of the United States, and that kept storms very active. We saw cooler weather coming around this trough as well. So you can imagine that the ocean temperature pattern when that occurred looks something like this. Very warm water hugging along the west coast of North America, off the Baja toward Hawaii. These were years when this set up that we saw a lot of hurricane activity, not in the Atlantic, but instead in the Pacific, right here in the Pacific. Whereas when we had the other phase, when it was quite hot in the Midwest, we had more hurricane activity here over the, or typhoon activity over the West Pacific. So it's all kind of interconnected and interrelated. And that is why we continue to stress that if we're going to look at that long-range forecast for what summer is going to eventually give us, it's going to be watching these ocean temperatures and how they evolve. So that's why I just spend so much time on that. In the nearer term, we can look at other factors that are subseasonal in the way they fluctuate. We can't forecast them on a seasonal basis. It's not possible yet, but we can look at them in a subseasonal way. And one of those is shown here. Global wind oscillation or atmospheric angular momentum. Doesn't matter. We can look at this change in the flow of the westerly component of the atmosphere as a function of latitude. Okay, so let me show you what I mean. There's the equator, and you see this line right here versus the envelope of colors, that shading. What you notice is that from the equator to about 30 degrees north, the magnitude of the momentum currently, which is here, is below average. Yet once you get into the mid-latitudes, the magnitude of atmospheric angular momentum is higher than average. So there's a lack of momentum in the tropics and subtropics and a surplus of it in the extratropics. You can see it maybe better over here by looking at the difference. There's the lack, there's the surplus. This is what's got our jet stream cranked, and I do not think that this has anything to do right now with what the MJO is doing. I think it's related to it and more related to the La Niña, but not necessarily the MJO. But this is what we get out of this, and we talked about this on Thursday. I don't see any blocking. We're going through mid-April, all the way out here to April 21st. And I see an extended Pacific jet. I don't see any high or low blocking. I don't see anything slowing this pattern down. And the net effect of that is I don't have any reason to say that what we've been seeing is going to slow down. I also see this. I see that the Pacific North American pattern, which is negative now, is going to climb. So the pattern is going to shift around. The East Pacific Oscillation says the same thing. It's going to climb. But I can't really say that it is going to be this permanent shift overall in the pattern because I still see strong trade winds here. Why we're going to lose our MJO signal is it's no longer butting up against really strong, well, either I could say westerly winds, but maybe just less strong trade winds. In other words, I don't have a real reason to say there's going to be strong rising motion, but it's going to be somewhere in this vicinity. And as we talked about last week, remember how the models were saying, bring it way out here into the West Pacific, the MJO? Nope, it's now crashing back again and will likely come back into this area. So I'm stitching this all together because this seems to be wanting to put the atmosphere on repeat. And that's what we need to be talking about. Maybe another way to look at it is to take a look at the Southern Oscillation Index. We haven't looked at this in a while because I've just been telling you that we've had this resurging La Niña, but it's got to be above a value of 7, which is here. And since March, it's really cranked up all the way to a value of 14. Came back down a little bit at the beginning of April, but it's back up here again. Now, what do we do with this? Because I would say that right now that the La Niña going on is going to have the biggest control in our pattern in April and possibly into May as well. So we know this from history that this is what we might end up getting. Let's take a look at our correlation with temperature in the Southern Oscillation Index. So when you look at the color pattern, it's going to be telling you where there's warmer colors. It'll be warmer than average, with the Southern Oscillation Index being positive, which it is, and the cooler colors are cooler. So notice across the northern interior of the U.S., specifically the Northwest, we see risks of being cooler. We can also see it's near neutral, but possibly on the cooler side of it here over the east as well. If there's a place that's going to be warm, it's here, right? What about the precipitation side of this? Now remember, the Southern Oscillation Index right now is positive. So on the precipitation side, what we have to understand is if there's a negative correlation, these colors mean drier. And the warmer colors mean wetter. So we're wetter in through here. We're wetter across a broad section in through here. And what I want to now show you is why I think that this La Niña's got the biggest hold on the pattern. This was the brand new update this afternoon from the European model. It goes from now all the way through the end of May. So we're seeing this big system curl through here, bringing in the precip. Very consistent. We then see the wetter conditions from the mid-south into the east, the tight planting windows we've been discussing now for a while. Are we going to get a stretch of 10 to 12 days at some point in May? Possibly, yes, we could, but I don't think it's going to come until we get into May for that to happen. Where's the risk of drier? Where we continue to see it in this area, down to California. But better precipitation here, as of late, is going to be a critical part of this. Now watch, on the temperature side of it, I don't think you'd be surprised to see this. Where's the warmth here? Well, historically, when there is positive southern oscillation index, that is where it's warm. And if we come back to it again, the risk of being cooler in the northwest, cooler in the northern United States, and cooler shots here exists as well with this pattern. So I think the La Niña's dominance is what's affecting this spring weather. And no, you asked me 2 months ago if I thought the La Niña would still be kicking like this. I did not. I absolutely did not. It is also responsible, because of that transfer of heat and momentum out of the tropics, for giving us this wave right here. Now we've seen some of the momentum in the Pacific jet stream getting farther to the south, but this is a powerful short wave. And at the surface, take a look at what the winds are doing right now. They're cranking up this big low in this area. By the way, we got to watch this one as well. That's going to be our next system. I'll talk about it in just a few seconds. But given that this is the wave coming out, it's about to eject into parts of western Nebraska, Wyoming, and getting into the Dakotas, it's packing a punch, because this is our current all hazards weather map as of this afternoon on Monday when I'm recording. We have, let's just start from west to east, winter storm warnings, winter weather advisories throughout the mountains. This is all in pink here, the winter storm warning, and this area is all blizzard warning. To the south of it, all of this is wind advisory, wind warning, high wind watches, and this is all red flag warning. Out ahead of it, we have a tornado watch right here in this place, and we're already seeing some big thunderstorms roll through that area, and this is in the afternoon on Monday. So there's lightning in the west. There's also storms right down here we're keeping a close eye on, and that's an area that I'm really going to have to focus on, because so far this year, this is a great graphic put together by the Storm Prediction Center. They just kind of keep overlaying those counties that go into tornado watches, and so you can see where the darkest shades of kind of pink or red here would tell us where they've had the most. And our newest one is going to be sitting right inside here, because the Storm Prediction Center has been on this area now for 3 days, and you can see that that's where they just issued the latest watch in parts of eastern Oklahoma, a corner of Texas, but mostly Arkansas, where until 11 o'clock tonight they've got a tornado watch. Now looking at it on satellite, I was just watching this today. You can see this system. This is just the beginning. This is the wave that's out ahead. The big wave is back here. You can start to see the storms popping. In fact, let's just zoom in there a little closer. How about with this view? And now you can see the location of the driest area. That's actually this is great. There's the edge of the dry line. Almost a triple point sitting right in through here. And if I kind of go back and forth, you can see that's where the storms are popping. There's something else neat about this animation. Can I go in a little farther? How about, let's go right here. There we go. Now I was watching this carefully. So can you see the storms popping on the line right here? There they go. But look at the smoke from the wildfires. Notice the direction it's going. That's the surface wind going that way. And I'm sure some of you see this little guy right here. You know what that is? Watch that go back in time. It's here. All the way back to this morning. That came off of the mountains. That was a standing wave in the flow of the atmosphere. That's a gravity wave right there. Isn't that amazing? I could look at this stuff all day. But wildfire smoke, where we do have the red flag warning today. So where's it going after this? Well, that dry line's going to recover pretty quickly. So you can see that here's where we were expecting it this afternoon, right here. And then, whoops, let's get to 7 o'clock right there, okay? Now, this is a map of humidity. Dew points. What you see is that by tomorrow morning, we've already recovered that whole humid, unstable air mass back to the west. And as we watch out through tomorrow night, that's when it starts to advance. And it's going to be along this boundary, this humidity boundary, in which we're going to see these storms pop. So getting into tomorrow on Tuesday, an enhanced area that extends from Texas all the way to Iowa. The storm system is going to be very slow moving from here to here. So that means by Wednesday, we've only shifted that over to parts of Illinois and Indiana, down back into the Mid-South. Now, to see how this all unfolds, let's go to the high-res NAM model. So starting off this evening, about 6 o'clock, let's play this forward. So in the Intermountain West, there's the low right there. It comes spiraling through, while the lingering boundary is where the storms are currently firing. Look at how tightly spaced the isobars are here. Very, very windy conditions. That low emerges tonight into tomorrow morning, somewhere here in the high plains of Wyoming, Nebraska, and South Dakota. And as it comes out right there, we can see the depth of this upper level system, producing a blizzard on the backside with very strong winds out of the south and southwest ahead of it, and on the western side of this coming out of the north. So this then pulls this elongated front. We should expect to see kind of an elongated frontal squall line here in the overnight hours on Tuesday into Wednesday, and that continues to press east, and by Wednesday afternoon and evening blow up storms again right in through here. But I just went through almost 2 days, and that low has only made it to here, still sitting over North Dakota, bringing in heavy snows on the backside. You'll see how much in just a few seconds. This will have a very large dry slot on the backside of this as the system continues to progress forward. But to see where it goes from here, I got to flip over to our multi-model analysis, the GFS on the left and the European on the right. Biggest difference is from last Thursday. Do you remember last Thursday I said, wow, the models were digging this trough way down deep? It was actually the European that was doing that. Then it, over the weekend, trended back farther to the north. I mean, that's a huge difference in just 3 days of forecasting. But that's why this system emerges in Nebraska versus coming out in Kansas. And the worst part of this is that robs Nebraska for moisture. So that system, by the time we get into Thursday, is curling up into parts of Ontario, had strong winds and snow on the backside through the Red River Valley of the north. And exactly at the same time that system gets out, the next one starts to barrel in here into the Pacific Northwest. So you can see the low curling out this long front like this, huge dry slot on the backside. It'll be something to see on satellite. Now, as this goes on into the weekend, the next system comes pushing in to the Pacific Northwest, hitting California, Oregon, Northern California, desperate for this moisture. And that system then pulls in just like the other, more moisture, such that by Sunday, this would be Easter Sunday in the morning, we're going to be watching out for storms in this area. What's going on the backside, though, is more snow for Montana. More snow, as you see here, getting back into parts of the Midwest. You know, this is our outlook for Monday. Going forward into Tuesday, the models do show something similar here in the position. There's a little bit a difference in the timing of this by next Tuesday, but you can see GFS here, Europeans a bit farther to the south and through here. But the result is another vigorous system that comes through early next week. So we have 2 of these lined up. Now, we put all this together. Let's go out there and look at total snowfall. Let's see if we got a good update here. Well, this is from the 0Z run. I'm still waiting on a good update, but I'm going to show you snowfall in the west. Because what I like to see out of these next couple of systems, look at the Cascades in Oregon, the Klamath Mountains, the Northern Sierra here. We need this snow big time. And there's some places here that could pick up over 2 to 3 feet of snow. Better snows into this part of the Rockies. This is also an area that we desperately need some snowfall. When you come over to the Midwest, this is going to be the area we're going to target. Now, this is using a 10-to-1 ratio, but there's the potential in here for picking up over a foot of snow from this part of Montana through North Dakota. If you would have looked at these model runs last week, they were hammering this area with the snow. That's that northward shift in the track. So what are the probabilities of getting at least 6 inches of snow? Well, that's shown here. And what are the probabilities of getting a foot of snow? That's shown here. So really, it's that coastal Oregon, parts of the northern Rockies, and then here into this part of North Dakota. Now, that is an area that desperately needs the snowfall. As we've been talking about, the headwaters on the Missouri River here have missed out on snow throughout much of this season. We know that the Klamath Mountains and the Northern Sierra are at like 20% of snowpack for this time of year. And the interior of Oregon desperately needs more snow. So these are areas that really, really need to see the snow. And yeah, it's coming in April, but we needed to get it there. We need the moisture out of it. What's the total liquid equivalent in through here? About 1 inch to 1.5 inches, which is fantastic. That's going to hit hard on that drought area. Okay, total precip if you melted it all down and added in the rain. Areas that don't need it are here. This is over the next 7 days. You can see here that there's going to be parts of the Mid-South that are not only seeing strong storms, but some of them capable of delivering 2, 3, 4 inches of total liquid equivalent. Our problem is a place that needs it back here in the high plains of Texas, Oklahoma, Kansas, Nebraska, Colorado, and New Mexico are not. So this is our setup for the next 7 days. To pick up on kind of that same theme, this is the probability of getting at least an inch of rainfall, or total equivalent if you melt down the snow, through the next 7 days. So we're hammering once again the eastern Corn Belt and the Mid-South. From there, what's the pattern doing by week 2? Well, it's open and moving. So we see that early next week, that next big trough comes slamming into the Pacific Northwest, while cold air exits under this one from Easter Sunday all the way through midweek next week. And this ridge is short-lived, because all the way out by day 10, that's the 21st, into the 23rd, 24th, 25th, what do the models do? Drop in another trough. So we can't rest on severe weather in this area, and 2022 has been extremely active with regard to that. So we're starting to see it show up in the models. This is the full week 2 forecast. Now we see those systems coming through, so we're above average precip here. We're expecting to see another system come out while one leaves the East Coast. So this is really going. On the temperature side of things, what I'm concerned about is that kind of post-Easter cool down across the East. So NOAA released this today, and this kind of follows what we've been talking about for about a week and a half now, that getting here past Easter, there is significant risk of colder air coming into this side of the country, which is, of course, delaying all of the field work we want to be doing for planting a crop. To see the next 7 days of temperatures, here we go. This was Monday's highs. We've already got these. There's Tuesday. Look at that warm sector opening up here. Going into Wednesday, brutally cold air, Arctic air coming in on the backside. And of course, that comes sliding through by Thursday into Friday, Saturday, and this would be Easter Sunday. On Easter Sunday, the country just seems to be split north-south on who's much below average in temperature and who is well above. So pretty cold Easter Sunday for much of the country. It's what follows that I'm concerned about. So through the next 7 days, this is where we're expecting frost. It's after the next 7 days, well, that's a bit too big of an area, but after the next 7 days, I'm concerned about this region seeing that late frost getting down into here. Because if you watch this forecast, this is a 5-day sliding window of temperatures. You can see the influence of that trough showing up after Easter. See where we are? We're on the 20th, going out there to the 23rd, 24th, 25th. And just like we expected to see with the behavior of the Southern Oscillation Index, we're cooler here, and warm in the middle. This is all kind of panning out to really paint an interesting picture with relationship to that La Nina. Okay, let's finish up with South America. We've seen since the beginning of April dry conditions that have been in the eastern growing areas expand over into Mato Grosso. This is a critical time. This is like mid-July for the Safrinha crop, and it just went over dry in that area. The extent of that drought, let me slide down here for you. When you look back from March 6th to April 5th, was mostly in the east, hitting probably about 20 to 25% of the Safrinha crop with very dry conditions. Well, with that MJO collapsing, we're seeing problems in that this area, which had seen better chances for better rains, is now not. The heavier rains are down south where it's been wet for a while. We also see drier conditions showing back up in Argentina, especially along the Paraná River, which comes out through Buenos Aires. So very dry conditions are split with very wet in the central part of South America, and we've seen that for quite some time. To finish, though, take a look. This is the new long-range outlook for the next 30 days. And there's not much point going past the next 30 days. This would take us out to April, May 21st. And that 30-day time period, so April 21st to May 21st, shows this area drier on that Safrinha crop. Now you say, why is this important? Well, let me just show you. In Mato Grosso, April total precipitation versus May. Well, May is less than half of normal of what April is. This is the shutdown of the monsoon. So if it has been dry as of late, we see drier over the next 15 days, and the new model runs show drier in the longer run, we may just start to see those numbers peel back a bit on that Safrinha crop. And I know what the USDA just said, but I want to keep an eye on the weather side of this to see if it's going to change what those next reports will share. So we covered a lot today, but I appreciate your attention. I'll talk to you again on Thursday. Thanks.